this is a very easy way of extending your range on a vessel. You have the battery swap option then that you can quickly swap them in a short period of time. Like the old stagecoach, you have the horses waiting for your horses going, that kind of thing. I think that's going to be the way we will overcome the distance problem with short sea shipping.
Hi everyone, welcome to the Climate Confident Podcast. My name is Tom Raftery, and with me on the show today, I have my special guest, Chris. Chris, welcome to the podcast. Would you like to introduce yourself?
Hi, Tom. Yes, my name is Chris Kruger, and I am the founder of AYK Energy, a marine battery company.
Okay. And what are you making marine batteries for, Chris?
Well, marine batteries are really used for propulsion today. In the past, marine batteries was used for communication and so on, but since 2010, the industry started growing, and we have now batteries that's powerful enough to be used for propulsion. And as such, we can use it on really any kind of vessel. It makes the most sense for short sea shipping. That's where it makes the most sense, but it can be used anywhere for hotel loads, for propulsion, for anything like that.
And how did you get into this space?
That's an interesting one. I'm an electrical engineer, and I was in the semiconductor industry. Being in Vancouver, which is really a hotspot for lithium-ion batteries. The first lithium-ion battery was built there by Ewan Wally, and they're still in Maple Ridge. When I was looking around, the semiconductor industry is very much a rat race, and I got tired of it. I said I want to do something for the environment. As you grow older, this happens. I discovered the lithium-ion battery. There were guys very close to my location, and I started chatting with them, and eventually they had a need, and I made the move. That was with automotive first, and then in 2010 I joined Corvus, and as the first engineer and I built the team. So that's how I got into the marine space.
Okay. And how or why did you go about setting up AYK Energy?
Yeah, AYK is really in response to the need from the industry for a more cost-effective battery. The marine battery is really a lot more expensive than what the batteries for stationary is. And the reason for that is mostly because we don't have the volumes. And we also manufacture this not in a country where manufacturing is what they do. I have now set up a factory in China, in Suhan, and we are very close to the supply chain. And by doing that, we can bring quality from our experiences since 2010 to the table to make sure we use best known methods and we have the safety we require, and we can use the benefit of the Chinese manufacturing know-how to bring the cost down. And that was really the main reason for that.
Okay. And in the 10 years or so you've been in the space, what's been the most surprising thing you've come across or learned?
Yeah, that's an interesting one. The surprising thing is that people will talk about we have to go green, we have to do something until it hits the bottom line, and then they're not so interested anymore. So if it's not subsidized, then it's very difficult. Now that's changing. I see more and more people are getting excited about this, and of course the prices of batteries come down. When we started in 2010, it was more than $1,000 a kilowatt hour, and I just released a version of a battery, a high energy, low power battery at $300 a kilowatt hour for the marine space. So you can see it's dropped quite a bit. So I think the $300 is the area psychologically where people start saying, well, this starts making sense. And your ROI, your return on investment, can be a lot quicker.
And marine electrification does kind of seem to be picking up steam a bit, but how far are we really from seeing widespread adoption across different types of vessels? And what do you think, apart from cost, what do you think is the most significant barrier to entry right now?
Yeah, I think complexity, that's a big one. It's very difficult to be a crystal ball gazer. In 2012, we said, oh, the big tsunami is coming. And it didn't really span out. It took quite a while for our batteries to take off. But what I've seen in the last 6 months here, or it started picking up in 22 already, is that the batteries we quoted were kind of test batteries, smaller batteries, a few hundred kilowatt hour, with a few bigger 1 megawatt hour battery sizes. And nowadays, 1 megawatt is the norm, 5 megawatt is common. We do 25 megawatt hour. We actually are about to get orders for 25 megawatt hour, and we quote up to 100 megawatt hour. So by 2030, we will for sure have 100 megawatt hour installed somewhere. So it
Wow.
looks like there's a lot more uptake. I can say also that by talking to people, I think we can with confidence say that any new boat has some form of battery on it. Any new built vessel, not
Right.
retrofits, the new built vessel will have some form. If it's not propulsion, it's hotel load or something to help smooth it out.
Okay. Well, when we talk about decarbonisation of shipping, batteries often come up alongside hydrogen fuel cells, or some people
Yeah.
talk about the potential for maybe ammonia or things like that.
Mm.
Could you walk us through how these technologies compare, both in terms of emissions reduction and, more importantly, I guess, practicality?
Yeah. Well, I'm a battery guy, so I'm a bit biased. But in any case, you need battery for all of these green fuels. There's always a time when the green fuel cannot supply the power as quickly or wind down as quickly, and that's where the battery comes in. So fuel cell fuse batteries. The battery, the advantage, if you let's just compare to hydrogen, you do not have to store this energy and move it. It's not like hydrogen that you have to have special supply chains. You can use the current supply that you have. Of course, it costs money to upgrade it, but there's other ways you can deal with that as well. You can have green energy being generated by solar or
Mhm.
wind, and you can get a very high efficiency from that electrical power generated to it being used. So the well to wake, the old term that we use, the well to wake ratio is very high. It can be above 90%. If you look at hydrogen and you use the electricity to create the hydrogen, generate it, you move it, you store it, and you use it again with all the efficiency losses, that's way below 30%, maybe 40, but I've read numbers down to 20% in some cases. If you can get to the place where you can use batteries, then I think a battery is way more efficient. The drawback, of course, is distance. Batteries will be ideal for short sea shipping. So anything close to the coastal waters. Across ocean is not there yet. There's where your hydrogens and things like that comes in. It's really a much cleaner and easier way to deal with your energy than having a fuel tank on your vessel that you have to deal with and charge and so on and so on. So I think batteries, in the long run, batteries will become the dominant means of
Mhm.
storing energy for short sea shipping.
Okay. And longer term for transatlantic or container shipping, do you see batteries eventually taking that place as well, or will it forever be some kind of hybrid?
I actually see that. I think that it'll take longer,
Mm.
but as you get the energy density to go up. So just to quote a few numbers for you today, at the cell level, the LFP that we use, or maybe let's talk about system level. The system level, the best we do is 140 watt hour per kilogram. The NMC guides can take that up to 166 watt hour per kilogram. If you go to solid state, and you do true solid state batteries, which is still maybe a decade out, but it's getting closer and closer. Those batteries, you're going to see energy densities of 700 and more at the system level, maybe even up to 1,000 watt hour per kilogram. So when it gets to that kind of level, now it becomes more feasible that you will be able to do cross ocean. We're already working on things like that, on preparing for that kind of solution. It's definitely a possibility.
And you said 1 megawatt hour, 5 megawatt hours are pretty common and standard nowadays. I mean, just
Yes.
for people who are listening who might not know what that means, to kind of contextualize it, I drive a Kia Niro EV, and the battery in that is 64 kilowatt hours, and a megawatt hour is
Mhm.
obviously 20 times that, and then of
Correct.
course another 5 times again for 5 megawatt hours. So
Exactly.
we're talking big
Exactly.
batteries here.
We just installed a 12 megawatt hour battery already on two vessels. I believe this is the biggest one today. It's not the biggest one that's on order, but the biggest one that's actually installed and has been sea trialed. It's on sea trial. The vessel is on its way from China to Europe. So it is here. If you think of 12 megawatt hour, then you can think how many automobiles that is.
Yeah, that's amazing. And when you say it's being used for propulsion, is it being used solely for propulsion, or is it some kind of hybrid drive mechanism?
Well, the vessel I just mentioned is a hybrid. They still use fuel. But typically, the ferries that's in Norway, there's a lot of full electric ferries. They're working on full electric tugboats. Tugboat is ideal for this if you can get your
Mm.
energy density up. And when you get to the 25 megawatt hour battery type, this is full electric ferries when we start getting to that. Definitely when you get to the 100 megawatt hour range, then you can do a sailing, like a 20-hour sailing with a very big vessel on that kind of battery.
You mentioned, the likes of NMC batteries versus LFP batteries. For
Mm.
people who are unfamiliar, what's the difference between these two?
Well, at the most simplest level, LFP is lithium-iron-phosphate and NMC has got nickel, manganese, and cobalt in the cathode. The iron phosphate, the reason we are going that direction, it's a much safer cell. So if you ever get into thermal runaway, it's a very slow reaction. Whereas with NMC, it generates its own oxygen when it goes into thermal runaway, and it becomes quite a violent reaction. So we design with that. It's a dominant chemistry NMC today in marine. Although I think the shift is coming to LFP because of the safety. And we design for the safeties, of course. The batteries are safe, but just the fact that when the batteries get so very large, 100 megawatt hour, you really do not want to have a thermal runaway that's going to propagate. So
Mm.
for that reason, the LFP is the more desired chemistry. And the argument people always make between the two is, look, with NMC, you can get much higher energy density. Well, today we can see that we are not at the same level with LFP, but we're not that far away. We within 20% or less at the system level, not at the cell level, at the system level.
Okay. And what is the difference in terms of price between the two?
Oh, the LFP is much cheaper because the raw materials, it starts with the raw materials, is much, much cheaper. And then on top of that, China, where we get most of the cells today, is manufactured in China. They concentrate on LFP. So if you look at pure volume, LFP has the highest volume that's being manufactured in the world today. And that's how we could get to this number of $300 per kilowatt hour. It's that manufacturing volume that allows that, together with the LFP. So with the LFP, you don't have exotics. If you look NMC, you look at nickel, manganese, cobalt. These are all exotic metals,
Mm-hmm.
and that drives the price up.
And so, given that, why are other marine battery manufacturers slower to adopt LFP versus NMC?
Well, it's this. I can only speculate. I think one of the things is that if you have a battery that's working on NMC and it is successful, it's safe and it's kind of the industry standard, then why change? It's a lot of work to change the LFP. The drawback of the LFP is that it's more difficult to determine the state of charge of the battery. It's got a
Mm-hmm.
very flat discharge curve, and not that it means a lot for a lot of the listeners. But your accuracy of your BMS has to be of measuring the voltages and currents has to be way, 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 way more accurate than it's required with NMC. Therefore, NMC is easier to work with. So there's a barrier that you have to cross over. But we see today that we get more and more RFQs, requests for quotations, where the owner says, I want LFP. I don't want NMC. So it is
Okay.
moving in that direction, but it'll take a few more years before LFP will be the dominant battery.
Okay.
There's
And
always space, there's even if you look at the battery space today in marine, there's LFP, NMC, and I left out LTO, which is a titanium battery. The
right.
energy density is really bad there, but it can cycle forever and very expensive. It has its place. There are certain applications where you need that. So you need to look a little bit at the application before you select your chemistry.
Interesting. And looking at the likes of the form factors, I mean, you mentioned cell versus system level, but what kind of form factor do they take in a boat? I can imagine
Mm.
there's a lot of container ships out there, for
Yeah.
example. Is it possible to put these batteries in those typical kind of containers that ships are already architected to transport?
We are actually looking at that today. This is kind of a common thing in the industry. People are just starting to play with it. Of course, one container is very expensive, so it's not something you do without having somebody you want to buy it. It becomes expensive, right? Exercise. But the typical levels you see in a 20-foot container today is about 1 MWh, quite common. We can push that up. We have designs up to 2.5 MWh in a 20-foot container. And we are now working in a 20-foot container, standard ISO 20-foot container space to have 5 MWh.
Wow.
And this is with LFP. It is moving in that direction. The advantage there is that your handling equipment is quite standard. If you are in any port where they handle this and maybe they have reefers they need to plug in electrically, then you have access to those kind of infrastructure. So that's something to consider. And on top of that, this is a very easy way of extending your range on a vessel. You have the battery swap option then that you can quickly swap them in a short period of time. Like the old stagecoach, you have the horses waiting for you and you're looking at horses and keep going. That kind of thing. I think that's going to be the way we will overcome the distance problem with short sea shipping.
One of the big topics in the EV space is, of course, the infrastructure. So how does that work with shipping, with maritime? I mean, there's an advantage that maritime has in that you only have certain number of ports. So people go from port to port or harbor to harbor. So there's obviously infrastructure in place, but is there charging infrastructure in place?
And one of the biggest problems that people have. It's very expensive to upgrade your electrical supply to a port. Just to get the energy there is so it's a benefit. You don't have that many. The drawback is if you make all the ships electric, you have no chance of charging. The solution is again this containerized solution. It is quite easy to truck the containers in and to swap them out with charge stations with green energy. So that would be the obvious drive for the industry, is to go to places where you can charge it with wind or solar or whatever, and you can have a constant stream of batteries coming through. And as your energy density go up, it becomes much more feasible to do this kind of thing.
It's funny thinking of shipping moving back to wind energy, which is where it kind of really started out.
Isn't it? It is, isn't it? Yeah. It is really the most efficient is the wind, It doesn't cost anything.
It's nice. It's nice. I like it.
Yeah.
Looking at global decarbonisation goals, I mean, we've seen a lot of big maritime companies talking about the fact that they're going to go green in their transportation. Maersk is an obvious one that comes to mind. How significant is the sector's shift to electrification in achieving those targets, and are we moving fast enough?
Well, we can never move fast enough. I think we're about a decade behind. We should have started a decade earlier. No, I think the move is absolutely there. You see more and more big companies. They put their money where their mouth is.
Right.
So they are starting to investigate the space very closely and trying to see what they can do to achieve it. In the end, it could be a lot more cost effective if you have the infrastructure set up to have electric propulsion, full electric propulsion, rather than having tariff diesel or something like that. We've seen a change on the diesel electric ferry I did in 2012. And that was still a fairly expensive battery. It was a 3.2 MWh battery, 2.7 MWh battery. The ROI on that was 1 year. The return on investment was 1 year. And it didn't all come from fuel savings. It was things like they took a diesel out and they run it on batteries as often as they can. They run the diesel that's remaining at high efficiency. Cleaning service goes down on the diesels, maintenance, things like this. It is definitely, if you can go full electric, it becomes a lot more cost effective. And you can see this with automobiles as well. When you start, I'm always waiting to see when but governments are going to step in and say, now we charge you for using electric vehicle on the roads.
Mm,
We need to get
yeah.
the tractor from somewhere. If fuel is not there anymore, what they can do?
Yeah, yeah, I can see that happening as well because, as you say, if people are no longer buying fuel, fuel tax is a big source of revenue for governments, so they will have to start charging by number of kilometers driven per year or something similar. I guess. Well, that's
Exactly, because if you charge from your own solar on your roof, which is quite capable or quite possible, then how
mhm.
do you tax for that? So it probably will go to another metrics than the energy. That's a different speculation we can add.
A lot, Chris, of industries are talking about lowering costs for green tech, but you're actually doing it with AYK batteries. Is that just a unique advantage of manufacturing in China, or is there a broader lesson here for scaling climate tech in other industries?
That's a very interesting question. I think we will find that when you can mass produce, then you are going to drop the prices. And there is definitely a tendency in that direction.
Mm,
So it's that mass adoption. You need to get to a place that you make enough of something that you can get the cost benefits from it. So with batteries in marine space specifically, this is where when we made the decision to manufacture in China, it was to get that advantage early on. We can benefit from that high volume manufacturing. So I would say any industry, you need to get to a place where you can make it cost effective that people can afford it. Or it gets in the realm where some people will say, yeah, this is something I can do. And to look at the automotive industry, it's getting there. Cars are getting to a point where it depends on who you talk to. There's some of the gearheads that says no, diesel will always or petrol will always be there. But I don't think it's true. The young people are starting to adopt electric cars. And when your
mm,
20 somethings or 30 somethings start adopting that, then the writing's on the wall, in my opinion. So it's
yeah,
that kind of thing. You need to get the volume. If you can get the volume in the technology, then it'll go. You either have to get subsidies and that's not good because then it gets a whole bunch of people in that's not really, shouldn't be in the industry. Or you need to have a work with some taxes or something and just plain old drop the price, make it cost effective. Not, the important thing here is it doesn't help to drop the price and not have a business for maybe future gains. You need to be
sure.
able to manufacture at a decent margin that you can survive. So
Mm.
but it's not rocket science, I guess.
Okay. And who primarily are your customers? Is it end users or is it ship makers or a combination?
Oh, it's really, it's really everybody. It starts with the owner. The owner must want it. Sometimes we get integrators convincing the owner. So the integrator for guys like Wärtsilä, ABB, Siemens, and they integrate the electric systems on vessels. I believe very strongly that as the batteries get bigger, the price component is so big compared to the rest of the electrical equipment that the yards, it's like your general contractor for building a house, the yards will start buying the batteries directly. Today it's not like that, or mostly
Mm,
not like that. The yards are going to buy it. At that point in time, if you are not established, it becomes a lot more difficult. If you want to buy a battery without a name brand, and now the yard they want to bring the price down, but they want something that's going to work. So the owner
mm.
still has a big say in this. It's not commodity yet, not in marine at least, but
Okay.
it's going in that direction. So when you ask who do we sell to, really we have to touch everybody. If you don't touch the owner and even the designer, you have just the marine engineers that design the vessels. You need to start there with the architects and the integrators and the yard. So it's across the whole board.
Nice.
Cool.
And you recently worked on the H2 Barge 2 in Holland, which integrates your batteries with hydrogen fuel cells. So, how much of the maritime industry's future do you think will rely on hybrid systems like this versus all electric?
I think we will have a time frame where there will be a need for hybrids, or the hybrids will be more. It's like a
Mm,
hybrid car as well. You do get electric cars, but the hybrids is kind of people want to. The range anxiety is always there. Having said that, the full electric vehicles, vessels, cars, doesn't matter. It's way more simple than a hybrid. A hybrid's a very complicated beast. So if you want to get the cost out of your transportation, then to go full electric is the obvious way to go. But it will take some time. So hydrogen, there's a big hype on hydrogen. People love the idea of hydrogen. I'm not a fan, but I will not go into that. It's a fuel. It's a fuel. So whatever fuel people want to use, hybrids is definitely today still the dominant, and it will take a bit of time. Maybe by 2030 we will see more electric vessels, full electric vessels. Maybe it might even be dominant by then. It's a possibility.
Good, good, good. And you mentioned earlier in passing solid state batteries as well. Are they like the holy grail that everyone's hoping for? And when do you see them becoming the standard?
Well, we have to get a little bit more technical if we want to explain that. But let me try and make it very simple. So solid state batteries, the idea is that you take the electrolyte that is flammable out of the battery and replace it with a medium that's solid. So now it's not flammable electrolyte anymore, and therefore the battery becomes way, 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 way safer. That's a big deal. You could also use things like different materials for your anode. So you can use high energy materials. You can use actual lithium metal for the anode. And that's when you go to lithium metal where it gets really safe. Today we have hybrids, hybrid batteries, so to speak. You have a semi-solid. So you still have liquid, but some solid. So to bond the electrical poles through the electrolyte to connect to get the ions to move, you need to have some kind of liquid. So these are not as safe. The energy densities might climb up to 400 watt-hour per kilogram at the cell level. But to really get to that solid state, it will be above 1,000 per kilogram. And that's going to take, in my opinion, before it's cost effective, it's still a decade out. It may be a little bit shorter, but it's a while because you need to get your supply chain under control. The materials are complicated to work with. Lithium is reactive to moisture. So just to manufacture the lithium and get it into the battery becomes a complicated thing. And then the volume, it's okay to have, we have these batteries today, but they're small, even a few larger ones. But to produce them cost effectively, where the LFP is today, this is going to be still a while before we get there.
Okay. And you mentioned the cycle life as well of LTOs being extremely high. Do solid state batteries have a similar advantage?
Well, not really. It's different aging mechanisms you have there. If you have the very high cycle or the very high energy density, then you have a solid lithium anode. So now instead of intercalating the ions in between the lattice structure into the crystalline structure between, it doesn't bond. You plate the lithium onto the anode and you unplate it when you go the opposite way. So it's a plating process. Mechanically, that creates a lot of stress on the battery. So I would say the aging mechanisms are going to change. Today, solid state cycle life is not as high potentially as other cells, definitely not at the LTO level. And the industry has to overcome that before the cycle life will be that high. The question is, do you really need that? If you look at something like a LTO, low energy, but it's got 80,000 plus cycles, where the standard battery today hovers around 4,000 to 6,000 cycles. So it can last that much longer, but it's 2-3 times less energy dense. You probably, with 10,000 cycles, if you do a single cycle a day, for instance, in 10 years, it's 3,000 cycles. It's specialized applications where you need that. I don't think that is, the aim is to get to the 5,000 to 6,000 cycles kind of cycle life.
Okay. A left field question, Chris. If you could have any personality, any famous person, alive or dead, fictional or otherwise, to be promoting batteries for marine transportation, who would it be and why?
Oh, that's a difficult question. I think I would like a guy like for instance, like Pierre Forrester, he would be a guy that I would like to, with a little bit. I think batteries are sophisticated, and he's one of my favorite James Bonds. So he's got that sophistication or sophisticated feel about it. So a guy like that. You can go to any of the power guys. You can take Arnold Schwarzenegger, but Arnold Schwarzenegger as well. It's a very powerful battery. So
Good.
yeah,
Good.
it needs to be popular, and batteries are becoming sexy, in my opinion.
Yeah.
People see it as sexy. The one thing that amazed me is the benefits that people don't know of when you're in an electric vehicle. If you're in an electric car, for those that have not been in it, it's quiet. It's completely a different experience. Even the sounds, the smells are different. So once you've been in an electric car and it has the same capabilities as a gasoline car, it's only the gearheads that loves the smell of diesel that will stay with it.
Yeah, fair enough. Fair enough. And I like that you mentioned that Pierce Brosnan is sophisticated. I got to think that that's in large part due to the fact that he's Irish as well as me. So I'll take that. So
there you go. Fantastic.
Super. Chris, we're coming towards the end of the podcast now. Is there any question I didn't ask that you wish I had, or any aspect of this we haven't touched on that you think it's important for people to think about?
Well, I think what's important is that you don't always have to look at price. This is one of my biggest problems I have with the industry. They compare the stationary batteries with what we do in marine, or they compare different batteries against each other. You need to look at the capability. Of course, price is important, but the first question you should ask is, can the battery do the mission I want it to do? And is it safe enough? Safety is really, really, really important. I think people should more ask those questions and say, here's my mission profile, and is it safe enough, rather than saying, I want a battery that's powerful, I want a battery that's got a lot of energy. And we should start putting ourselves out there a little bit. We should not have this range anxiety. We can design around that and give people the comfort. If you look at automobiles today, you can easily leave 500 kilometers. And when you start getting to solid state, it'll be 1,000 kilometers. It'll cost a bit, but that's the kind of thing.
Sure, but that it'll cost a bit keeps reducing as the battery prices keep falling year on year on year. So,
yeah, absolutely. But can you imagine having a car that can do 1,000 kilometers? And now this whole range anxiety thing, you drive to your destination. That's how far you can drive roughly in a day if you drive comfortably. And you go and charge it overnight. So that whole issue is gone when you can do that.
Yeah. And it's not that far out. There are some that are close enough to 1,000 already.
Very close.
So,
very close.
Cool.
Very close.
Chris, that's been fascinating. If people would like to know more about yourself or any of the things we discussed in the podcast today, where would you have me direct them?
I would say the best is to start at our website, www.aykenergy.com. We are announcing that all the time. And you are welcome to look us up on LinkedIn as well. You can find me on LinkedIn. That's maybe the easiest. I can keep my phone number and so on, but go to LinkedIn and befriend me there, and we can definitely take it from there. But from our website, if you're interested in our products, you can always do a query on the website, and emails will get to us.
Superb. Great. Fantastic. Chris, that's been really interesting. Thanks a million for coming on the podcast today.
Thanks, Tom. It was fun talking to you.